Hey guys, so I promised that I would share with you the X-ray fluorescence analysis that I did yesterday of the fallout that we had in the UK, which I think pretty well all of the country got onto their vehicles. And lots of talking, mainstream media about it being Saharan Sands, and then obviously an awful lot of chit-chat on various social media channels about what possibly was in it. So I thought, well, the best thing I could do is actually do some proper analysis on it. So what I did is we actually collected sample, which was then dried. I don't know if you can see that in there. It was dried, homogenized, so it's actually a completely liberated particle, so we don't get any cluster effect. And then it was analysed using X-ray fluorescence. I happen to use a thermoscientific Niton FXL, which is one of the best field mobile X-ray fluorescent units on the market, and I use it commercially in geochemical exploration. So this is the baby here, and all the analysis was done yesterday. I did it under 3 modes because I wanted to get full geochemical signatures. So that included me doing it under a soil analysis, which was what I typically do if I was actually going to do some work on soils. And then I ran 2 mining samples as well. Those were to show me the light elements and also the general mine pathfinder elements. So the only thing I didn't do is I didn't have time to do helium purging, which is what I would normally do for light elements. So when I'm talking about some of the rare earth metals, I would normally do a helium purge rather than having it in a normal air mix when I'm actually doing the analysis. But this was effectively, as good as it's going to get in terms of doing analysis on the fly and getting some real semi-qualitative results. So that being said, I've done the results. Now, what I wanted to do was I actually wanted to show people that I was comparing this against real data that was out there. So what I decided to do was trawl academic papers, of which I've published several. And I wanted to find some papers that had given me some comparative geochemical signatures to look for based on the mainstream media narrative that this was Saharan Sands. So what I did is I found 2 peer-reviewed papers. One of them was in the Journal of Engineering and Exact Sciences, and that was published on the 20th of August 2023, so it doesn't get much newer than that. And that was a comparative analysis of the microstructural and physiochemical properties of alluvial and dune sands of northeast Algerian Sahara. So that gave me a geochemical signature for a sand dune in the Sahara, using X-ray fluorescence. So using exactly the same instrument as I've got here, that paper was written. So that's one of my comparisons. The second one, which I think is more interesting, is I actually decided to look for a paper about atmospheric dust, because that's what they're referring to when they're talking about Saharan Sands. It's just media going, oh, it's Saharan Sands. It doesn't actually mean that. It doesn't mean it necessarily came from the Sahara, although we are going to look for the signature. So the second paper that I pulled, slightly older paper, so this was actually published originally. It's available on various channels, but basically this was originally published by the Department of Earth Sciences, Faculty of Sciences, Shiraz University, Iran. And this was published, let me just have a quick look, this was published in 2020. So not that long ago. And this is an assessment of geochemical and sedimentological characteristics of atmospheric dust in Shiraz, southwest Iran. So what that was doing, and there's very few papers on this, what that was doing was actually showing me the geochemical signature of atmospheric dust. Not space dust, atmospheric dust. So that's the second paper. These papers are available online. If you've got an academic subscription, you get them for free. If not, you have to pay for them. So those are the 2 papers that I used as what I call my baseline data. Okay, so hopefully, so far, you're following me. So this is part 1. This is 4 minutes in. So I'm going to break it now, and then I'll come back with part 2, just so people can sort of take this in bite-sized chunks. Thanks, folks.